The question is saying that a 1 meter long metallic rod is rotated about an angular frequency of 400 radians per second about an axis normal to the rod passing through its one end. The other end of the rod is in contact with the circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. We have to calculate the EMF developed between the center and the ring. Now there is a rod which is rotating about one of its end, and there is another end which is in contact with the axis, which is in contact with the ring, which has not been drawn in the picture. So we have to calculate the EMF generated between this point and this point 1 and 2. Now under given conditions, and the condition is there is a magnetic field that is parallel to the axis of rotation of the rod of magnitude 0.5 Tesla. So the magnitude of this magnetic field is 0.5 Tesla, and the omega is 400 radians per second. That has been given in the question. So we know by Faraday's laws of magnetic induction that EMF is induced when the conductor moves in the magnetic field, and induced EMF depends on the relative motion of the conductor and the magnetic field. And the formula for electromagnetic induction as per the Faraday's law is given by E, or the EMF, is equals to minus of d phi by dt, where phi is the flux, magnetic flux, defined as B dot A, where B is the magnetic field and A is the area vector. And now in this present case, the rod sweeps out an area as it rotates, changing the magnetic flux through it. Now, for the sake of this question, we will consider a rod of length L. We haven't given the measurement of this length, that is 1 meter. So let us assume that this is the length of the rod L, and there is a small element of length dx at a distance that is x from the axis of rotation. Now the motional EMF that is generated in this section is given by E is equals to B VL. We know that this is the formula for motional EMF. Now for this section, for the section of length dx, it would be equal to V times dx times B. Now V at the distance x in a circular rotation is given by V is equals to omega times x. So we can write it as B times omega x times L that is x. Now we will have to integrate this expression from 0 to L for the entire length of the rod. So total EMF would be equal to integration of B omega x dx from 0 to L, where B is the magnetic field, omega x is the V part of this formula, and dx is the length of the small section of the rod. Now after this integration, we will find out that EMF is equals to B omega L square by 2. And after substituting the values, we will get the value of 100 volts. So this is the EMF developed between the center and the ring.